Hello Tangam, welcome to GullyClassroom. This is the second lecture of the chapter Acids, Bases and Salts in CBSE 10th Standard Chemistry, Science Book Chapter 2, Acids, Bases and Salts. This is the second lecture taken in English. Okay, what are we going to see in this particular lecture? In this particular lecture, we are going to see about the chemical properties of acids and bases. Specifically, we will see how acids and bases react with each other. What's the next thing? How acids are going to react with metals and metal oxides. How acids are going to react with metal carbonates and metal bicarbonates. We will also study about how bases are going to react with metals and non-metallic oxides. Since this particular topic is slightly large and it needs to be taken slowly, I am going to divide the chemical properties of acids and bases into two lectures. The chemical properties of acids and bases will be taken in lectures 2 and lectures 3. Okay, let us start the first lecture of chemical properties of acids and bases. Right, before we get into this particular lecture, let me do a very short recollection of of acid base indicators. With respect to acid base indicators, you will find that all the indicators and their color changes and flavor changes are easy to memorize. Yes sir, but I am always finding it difficult to remember the synthetic indicators. The color change in synthetic indicators are slightly difficult to remember. So how are we going to counter it? Let me tell you a shortcut. This is a shortcut on how to remember the color changes of acid base synthetic indicators. Okay sir, what is the idea? Phenolphthalein. What does P stand for? Phenolphthalein. Okay, with respect to phenolphthalein, phenolphthalein is colorless in neutral solution. It is also colorless in acidic solution, but it is pink in basic solution. Phenolphthalein is pink in basic solution. Okay sir, what about methyl orange? Methyl orange, M for methyl, O for orange. Methyl orange is orange in neutral solution. It is pink or red. It is pink or red in acidic solution. It is yellow in basic solution. It is yellow in basic solution. Okay, you can easily remember this. How sir? Remember the river in USA. What river sir? Mississippi. You are going to pronounce this particular word in the same way. PCCP. I am repeating myself. Phenolphthalein is colorless in neutral solution, colorless in acidic solution, pink in basic solution. You are going to remember this as PCCP. PCCP, like Mississippi of USA, PCCP of GullyClassroom. Okay sir, what next? You are going to remember methyl orange is orange in neutral solution, red in acidic solution. Red in acidic solution, yellow in basic solution. You will remember this as Mori. How are you going to remember? Mori. Not Mary Kana. Not Mary who had a little lamp. You are going to remember this as Mori. Right? Methyl orange in neutral solution, red in acidic, yellow in basic solution. Yeah, hopefully you guys find it easier to remember these particular codes for acid base synthetic indicators. Okay, now let me divide the board into two and let us start our chemical properties of acids and bases. Chemical properties of acids and bases. Yeah. I think it is slightly biased towards that side. I want to redraw this line. Kindly accommodate me. Yeah. Is this line somewhat okay? Anyway, let us start the lecture. First, I want to understand what will happen when acids and bases combine with each other. When acids and bases combine with each other. Let us write bases plus acids. Bases plus acids is equal to. Let us take a couple of examples. A very famous base is NaOH or sodium hydroxide. Sir, what is the other name for sodium hydroxide? Sodium hydroxide is also called as caustic soda. Sodium hydroxide is also called as caustic soda. Why is it called as caustic soda? Because it can burn the skin off. Sodium hydroxide has the burning nature. This caustic means burning or corrosive nature of sodium hydroxide. Sodium hydroxide plus what am I going to add? I am going to add hydrochloric acid, dilute hydrochloric acid. Here when I am, okay, not necessarily dilute, but I am going to add hydrochloric acid. What will happen? The OH ion from sodium hydroxide and H ion from HCl will combine to form water. This NaCl will combine to form sodium chloride or salt. Sodium chloride or salt. Let us give another example. I am going to take KOH, potassium hydroxide. So in potassium hydroxide, I am going to add once more hydrochloric acid. Here, hydroxide ion, OH ion from potassium hydroxide will combine with hydrogen ion from hydrochloric acid, and once more you will get water plus what is the salt you are going to get? KCl. So you will get KCl. Right, sir. What is the next thing we are going to do here? The next reaction we are going to write here is, let me go for MgOH twice, magnesium hydroxide plus H2SO4, sulfuric acid, which is indeed called as the queen of chemicals. Why, sir? You are going to use sulfuric acid in so many different reactions. Here you have OH, which is the hydroxide ion from the base, hydrogen ion from the acid, combine with each other to form H2O or water. The salt they form is MgSO4. The salt they form is MgSO4. Okay, let us do a very small analysis of these salts. Let us do a very small analysis of these salts. Sir, what is a salt, sir? Sir, what is a salt? Salt is nothing but a combination of a positive ion and a negative ion. Here the positive ion is sodium. Why is sodium forming a positive ion? Sodium atomic number 11, electronic configuration is 2, 8, 1. It will easily lose this one electron in order to form what, sir? Neon configuration. In order to form neon configuration 2, 8. In order to form neon configuration 2, 8, sodium will easily lose this one electron. Since sodium is losing electron, it is called as a metal. The basic definition of metal is, if an atom loses electron in order to attain noble gas configuration, it is a metal. And because metals are losing electrons to attain noble gas configuration, the metals are also called as electropositive. The metals are also called as electropositive because they are losing electrons in order to attain noble gas configuration. Sir, what about the Cl, sir? The Cl atomic number of chlorine is 17. Here the electronic configuration is 2, 8, 7. I am going to gain one electron, not myself. Chlorine is going to gain one electron to form an electronic configuration of 2, 8, 8, which is in fact argon configuration, noble gas argon configuration. Here, since chlorine is taking one electron from outside in order to form a negative ion, it is called as a non-metal. Okay, the non-metals, so take electrons from outside to form complete noble gas configurations. They are called as electronegative. Why, sir? Because they are forming negative ions. They are taking electrons from outside and forming negative ions. Here sodium is forming Na plus, which is in fact a positive ion. Na plus or positive ion is called as a cation. Here chlorine is forming Cl minus or anion. Negative ions are called as anion. So this positive ion and negative ion join with each other due to their force of attraction. Positive and negative attract each other. We have studied in lower classes, haven't we? Positive and negative, a positive charge and negative charge attract each other. So this attraction is forming a bond. This is basically a salt. Each and every salt can be broken into a positive ion and a negative ion. I am repeating myself. Each and every salt can be broken into a positive ion and a negative ion. Here the positive ion is usually a metal which is electropositive because it loses its electron in order to attain noble gas configuration. So if an element loses the electron to attain noble gas configuration, it is called as a metal. If an atom gains electron in order to attain noble gas configuration like chlorine, it is called as a non-metal because it is forming negative ion. It is called as electronegative. Sir, how am I supposed to remember? Positive ions are called as cations, negative ions are called as anions. There is a simple code. Let me tell you. If you have cats in your home, you will always feel relaxed and entertained because cats by nature are playful. So by looking at them, you will always feel comfortable and happy. So positive. Cation is always positive. Sir, what about anion? There used to be a teacher in my primary school called as Animus. She used to always behave very tough with me. She used to always scold me. So dedicated to her honor, what did I do? I remembered all negative ions are Animus ions or anions. All negative ions are anions. All negative ions are anions. Yeah? Okay. So that's basically an idea of metals are electropositive, non-metals are electronegative. So each and every salt can be seen as a positive ion and a negative ion. For example, potassium, atomic number 19. 2, 8, 8, 1. So it will lose one electron and form a positive ion. Chlorine will form a negative ion. In the same way, MgSO4. What about magnesium, sir? Atomic number 12. 2, 8, 2. The electronic configuration is 2, 8, 2. It will lose 2 electrons to form neon configuration. So it will be 2 plus SO4. You have already studied in 9th that the charge in SO4 is 2 minus. The idea is the number of electrons lost by the metal will be the number of electrons gained by the non-metal. I am repeating myself. The number of electrons lost by the metal, in other words, the number of electrons lost by the cation will be the number of electrons gained by the anion. Are you getting comfortable with this idea? I want to write one more example. Let us write CaOH twice. What is CaOH twice? CaOH twice is called as slaked lime. So if you take slaked lime with once more H2SO4 or sulfuric acid, what will you get? This OH twice and H2 will combine with one another and form H2O and will form H2O. What next, sir? Ca will combine with CaSO4. Ca will combine with CaSO4 and form calcium sulfate. With respect to calcium sulfate, atomic number of calcium is 20. 2, 8, 8, 2. So it will lose 2 electrons to form a positive ion, cation 2 plus. SO4 we have already seen it to be SO4 sulfate is already an anion and it has 2 minus. So the number of electrons lost by calcium is the number of electrons gained by the sulfate ions. Are you able to understand the idea of salts? Are you able to understand the idea of salts? Here, let us check whether all the equations are balanced. Here the number of hydrogen is 2 to 4. So here I will put a 2. Here also I will put a 2. So the equations are balanced. The equations are balanced. Yeah. That's basically acids and bases. Acids and bases combine with one another to nullify the effect of one another and form water plus salt and form water plus salt. Acids and bases. Acids nullify or neutralize. Let me write the word nullify. Nullify means bring it down, bring it to zero. Null means zero. Null means nothing. Null means nothing. So acids and bases combine with each other to nullify the effect of each other. So acids are basically corrosive due to the presence of H plus ions. Bases are usually corrosive due to the presence of OH minus ions. So the H plus ions from the acid and the OH minus or hydroxide ions from the bases combine with each other to form water, and because they are combining to form water, they no longer act as corrosive, they lose their corrosive properties, because the OH minus ions from the bases and the H plus ions from the acid combine to form water, they lose their corrosive properties. Okay sir, let me ask you a question. What does bee sting contain? What does bee sting contain? What does wasp sting contain? How am I supposed to counter bee sting and wasp sting? Okay, let me help you remember this. Bee sting contains acid. Bee sting contains acid. ACID. So in order to neutralize this acid, you will add base. You will add a base. So the acid from the bee sting and the base you have added will combine to form water, and once water is formed, once the bee sting's acid is neutralized, you will be relieved of the pain from the bee sting. You will be relieved of the pain from the bee sting. In a similar way, let me do a very fast recollection. Wasp sting contains a base. Wasp sting contains a base. So in order to neutralize this base, what are you going to do? You will simply add an acid. The base from the wasp sting and the acid that you have just added will combine together to form water, and once more, after water is formed, after the poison, the basic poison from the wasp sting has been neutralized, you will be relieved of the pain. You will be relieved of the pain. Okay, sir, how am I supposed to remember this? Kana, there is a very easy way. Let me help you. What is before B? Before B, in the English alphabets, before B there is A. So bee sting contains acid. What is before W? Sir, before W there are so many alphabets. Come on, just proceed towards the starting of the letters. Towards the starting of the letters. As you proceed, you will encounter B. So first you are encountering B, which means wasp sting contains base. Wasp sting contains base. So when you are bitten by a bee, you are being injected with acidic poison. In order to neutralize the acidic poison, you will put a base on your skin. What kind of base, sir? Good bases in our home are, you can use slaked lime. Slaked lime is a good example for a base. Usually people who chew palm leaves or betel leaves will have slaked lime in their homes. So you will put slaked lime, or you can also use what? Soaps are also basic in nature. So if you are bitten by a bee, you can simply wash your hands with soap. You can simply wash your hands with soap. What about wasp stings, sir? Wasp stings are basic in nature. Wasp stings are basic in nature. It has to be neutralized with the acid. What kind of acid do we have in our home? We have lemon, which has citric acid. So if we are bitten by a wasp, we can put some citric acid or lemon on it, or you can also put some tartaric acid or imli, tamarind, tartaric acid, imli or tamarind on it. Tamarind on it, and that will help to neutralize the base. That will help to neutralize the base. Is everybody comfortable with the idea of bee sting and wasp sting? Yeah? Cheers. Let me go for the next property. What is the next property, sir? Next property is, we are going to study about the reaction of acids with metals. Reaction of acids with metals. Okay, let us start the idea. Reaction of acids with metals. Before we get into that particular topic, I want to teach you something very interesting. Can I rub this particular thing of, do you want to note it down? Note it down. I am rubbing it off. Note it down. I am rubbing it off. Okay, we just saw about metals and non-metals. So metals are electropositive. Metals are electropositive. Non-metals are electronegative. Non-metals are electronegative. Okay, sir. What is the next thing? Let us study about metallic oxides. Metallic oxides are, okay, metallic oxides are basic in nature. Metallic oxides. What does this represent? This represents metallic oxides. Metallic oxides are basic in nature. Sir, what about NMO? Non-metallic oxides. Non-metallic oxides are acidic in nature. They are acidic in nature. Okay, sir, what is the reason behind this? We will study about specific reasons later in +1 or in 11th standard. Right now I am going to tell you a shortcut to remember this. Listen here. Here, I look at this M. If I am going to turn this M, am I getting a B? Here I have a M, metallic oxides. If I turn this M, am I getting a B? So metallic oxides are basic in nature. Metallic oxides are basic in nature. What about non-metallic oxides? How am I supposed to remember? Non-metallic oxides are acidic in nature. Okay, non-metallic oxides. Look at this N. Can I put a A here? Look at this N. Can I put a A here? So, non-metallic oxides are acidic in nature. Non-metallic oxides are acidic in nature. Sir, what is the use of this particular idea? We will be using this idea in order to get a depth of understanding in the following reactions. Okay, the first reaction that we are going to study after this is, we will study about reaction of acids with metals. Okay, reaction of acids with metals. Let us start the reaction. What is the first reaction? We will first go for zinc plus H2SO4. Zinc plus H2SO4. Usually we will react zinc with dilute H2SO4. Zinc with dilute H2SO4. Zinc is more reactive than hydrogen. So zinc will replace hydrogen from its compound and it will form Z10SO4 and hydrogen will be sent outside or displaced. Hydrogen will be sent outside or displaced. Okay, sir. Can we go for some other reaction? Absolutely. Let us go for magnesium. You are going to put magnesium with the HCl or hydrochloric acid. Here magnesium is more reactive than hydrogen. Magnesium will displace hydrogen from its compound. So you will get H2 because hydrogen is displaced from its compound. And MgCl2. Okay, what else? Here, give me the next reaction. The next reaction is, let me write Fe plus HCl, iron plus hydrochloric acid. Here also, iron is more reactive than hydrogen. Hydrogen will be displaced from its compound. You will get FeCl2. Here, this is nothing but ferrous chloride. This is nothing but ferrous chloride. Okay, sir. What else? Let me write another another reaction. Let me write another reaction. The last reaction that I want to write is aluminium plus H2SO4 or sulfuric acid. Here also aluminium is more reactive than hydrogen and it displaces hydrogen from its compound. You will get hydrogen here and you will get plus Al and SO4. Sir, how am I supposed to write this compound? Help me out. What is the atomic number of aluminium? 13. 2, 8, 3. So it will lose 3 electrons. I am going to put 3 plus here. What about SO4? The charge of SO4 is 2 minus. Can I cross it like this? So what will be the answer? The answer will be Al2 SO4 thrice. This is nothing but aluminium sulfate. This is nothing but aluminium sulfate. Hope you guys are getting this idea, right? So you are getting hydrogen plus aluminium sulfate. Here, the more reactive metal is simply displacing hydrogen from its compound. Hence, this is also called as single displacement reaction that we have learnt in the first unit, first chapter in the types of reaction. In the first chapter in the types of reaction, we did learn about single displacement reaction where a more reactive element will displace a less reactive element from its compound. In all these cases, the less reactive component is hydrogen. So hydrogen is displaced by the metal and hydrogen is sent outside. Okay sir, let me ask you a question. How can this hydrogen be detected? I want to detect hydrogen. How can this hydrogen be detected? In order to detect hydrogen, I will introduce a burning splinter. What is a burning splinter, sir? A burning splinter is simply a burning matchstick. Splinter means a piece of wood. So a burning splinter or a splinter of fire simply means a burning matchstick. If I am introducing a burning matchstick, immediately hydrogen will undergo combustion. Hydrogen is extremely combustible. Hydrogen is very combustible. So what it will do? It will burst. It will undergo very small explosions. Hydrogen, when undergoing combustion, because it is that much combustible, it will undergo very small explosions and it will give a popping sound. It will give a popping sound. So, when you are introducing a burning splinter, in H2 gas, what will happen? H2 gas will immediately burn with a popping sound. H2 gas will immediately burn, burn with a popping sound. Burn with a popping sound. That is how you will detect hydrogen. Are you able to understand this entire setup? Are you able to understand what will happen when acids and metals react with each other? The general equation can be written as acids plus metals is nothing but hydrogen plus metal salts. All these are simply salts where the first part is a metal, hence it is called as metal salts. You can check each and every one of the salts. Okay sir, what is the last topic that we are going to study today? We are going to study about the reaction of metals with we are going to study about the reaction of acids with metal oxides. We are going to study about the reaction of acids with metal oxides. Okay sir, what will happen when acids react with metal oxides? Let us take a good example. I want to take CuO. CuO can be simply written as cupric oxide. Cupric oxide is black in color. So you are going to take cupric oxide and HCl, which is going to be hydrochloric acid. Here you will get, what are you going to get? Before I continue this reaction, let me do a very short recollection. CuO is a metallic oxide, sir. Okay, Kanna. Sir, metallic oxides are basic in nature, sir. Okay, so this can be considered as a base. Okay, this is an acid. Sir, if acid and a base combine with each other, they will nullify each other and what will happen? Neutralization reaction will happen. So, you will get a H2O over here. You will simply get a H2O over here. And let us check. Here you will get this particular oxygen will combine with this particular H and you will get H2O. You will also get CuCl2. CuCl2 is a blue-green salt. It is a very famous blue-green salt. CuCl2 can be named as copper 2 chloride. I am going to call CuCl2 as copper 2 chloride. Yeah, because the oxidation number of copper in this particular compound is 2. The oxidation number of copper in this particular compound is 2. That's basically the reaction. So when a metallic oxide combines with an acid, it can behave as a neutralization reaction. Why, sir? Because the metallic oxide is usually basic in nature. It is always basic in nature, and a base combines with acid and undergoes neutralization reaction to form water and salt. What kind of salt? Metallic salt. That's basically the end of our lecture. That's basically the end of our lecture. Before I finish off our lecture, I want to do the balancing of all the equations. Mg plus HCl. So here there are 2 hydrogen. I will put 2 here. Chlorine, I have 2 chlorine. Here also I have 2 chlorine. It's not an issue. Here there is 2 hydrogen. I will put a 2 here. So 2 chlorine. Here also there is 2 chlorine. Not an issue. Here Al2. So I will put a 2 here. 2 aluminium. What next, sir? SO4 thrice. So I need to have 3 SO4 here. Hydrogen is thrice. So I will have to put 3 H2 over here. That's basically the balancing of all these equations. Let me check this equation. Here you have Cl2. So you need to have a 2 here. 2 hydrogen. Here also there are 2 hydrogen. Hence all the equations are balanced. Are you comfortable with how we did all the reactions? In this particular lecture is very important. We saw what is neutralization. We saw what are metals, what are non-metals. What is the nature of metallic oxides. What is the nature of non-metallic oxides. Then we saw about how do acids and metals react with each other. We saw the test for hydrogen. Hydrogen burns with a popping sound. Then we saw how bases and metallic oxides and acids. How metallic oxides and acids react with each other. This can be treated as a neutralization reaction. Yeah, we will complete the chemical equations, the properties of acids and bases in the next lecture. Yeah, hope I didn't bore you guys much. For me, chemistry is always interesting. Yeah, cheers and thank you for listening to me. If you like our lectures, subscribe to our channel, recommend our videos to your friends in the social media. Yeah, thank you, cheers and thank you.